Hi, in this video I want to show you why it is so important to have a very tight vacuum system in your rotary evaporator. So if we start the process, you will see that the evacuation process is pretty fast. We go down now to a set value of 100 millibar. As you see, we reached the set value now without any overswing or so on. This is the advantage of the very smart and very accurate working RPM pump. We are now at round about 100 millibar, and what I will do now is I will turn off the vacuum pump completely. So you see there is no active vacuum source anymore connected to the system. But what you will see is that the system itself, even if there is a rotating and stable part of the rotary evaporator, it will keep the vacuum level more or less constantly. There is only a very small amount of leakage inside the system, and if you consider what this means for your process, especially if you work with RPM regulated pumps, the influence of maintaining the vacuum inside of the system is very low. So you do not have any pressure waves inside or unstable vacuum values. You have a very smooth and a very constant evaporation. Especially if you have a hysteresis of 4 or 5 millibar, you see there is nearly no action required from the vacuum pump. With that, you also increase the separational quality during the evaporation process. Another important factor is that by using an RPM pump, you would also reduce the energy consumption significantly. We talk about more than 90% reduced energy consumption, as the pump do not have to interact very often, and if it's not required to interact into the vacuum, the pump is in a standby mode. As you can see, after 2 minutes we lost about 2 or 3 millibars. This is a pretty normal value for our very tight system, and you see there is no real need at this point to have an active vacuum source connected.